Okay, so members, how are you? So most welcome to our channel. So today we're going to be discussing the LU decomposition by complete pivoting. So I want to compute the LU factorization of this matrix B using the Gauss elimination. However, I want to be specific with complete pivoting. So with complete pivoting, what I mean is that whenever I'm creating the pivot, I have to make sure the maximum value within this matrix B is the one which is there. For example, it's a 4. If I'm pivoting respect to this position, I have to put a 4 there. So I have to play with the matrix using permutations. So my first permutation is going to be, so if I'm using P1, which is going to be, so with respect to P1, what do I want to do? Let's say I want to move A0 to there and bring down the lower row. So what do I do? So the permutation I use, second row first, then the first row will be in the middle, then the third row I have no problem with it. So that's how the permutation will look like. And I can also get another permutation Q. Okay, let us first do this. So you see that when I get P and B, this switches the permutation. So this will be 2, 4, 4, 1, 1, 1. This is 1, 4, 1, something like that. However, I need 4 in this position here, not 2. So what do I do? So I use another permutation Q. So using another permutation Q, can call it Q1. So now this one, it's going to help me move the columns. So permutations, if you multiply a permutation in front of the matrix B, this one is for rows. However, if you multiply a permutation behind, now here you're changing the columns. So here I will get the matrix Q. This is going to be, so this is going to be, so I want to change the column, so I can switch this to this. Check that the 4 is there. So this will be 4. No, I want to switch the first to the second, the first column to the second. So meaning even here we'll begin in this. The second is the one which becomes the second becomes the first, and the first becomes the second. Then the lower one, I have no problem with it, the last column. Therefore, when I multiply P1B with Q1, I will get 4, 1, 4. This is 2, 1, 1, 4, 1, 1. You can try to multiply yourself and see. Something like that. So now we proceed. So after getting that, we have to calculate for M. Can say my M1. M1, just as we did in the previous video, is given by I plus M1. This will be A1 transpose. So we say that this is the identity matrix 1, 0, 0, and this M is the matrix attained basing on our pivot. So the pivot is going to be in the first column, so you put a 0 there. Then this is going to be this 4 dividing this, and you put a negative. We have seen this in the earlier video. So this is going to be negative 1 out of 4. This is going to be negative 1, like that. Then the transpose, and then this is the transpose of our matrix. Because we're in column 1, that's why the first one is the one with the 1. If we're in column 2, then if our pivot is in column 2, then our 1 will be here and the rest are zeros. Okay, so we have done this earlier. So when you work this out, you find that you get something like this. It's basically easy. the identity 1 1 remains there, and this is the only column which changes, and here you have a 0. So after getting that, what do? You come and multiply. You come and multiply this M1 on P1 B Q1. So we come and multiply this M1. Our M1 is here, it is here, then this is M1, then my P, we got it here, so it's the one here. So then we multiply using row by row, row by column, column by column, anything that you prefer. Now from here we see that this one has to remain the same, this column, this row has to remain. I'm using row by row, 4 2 4. Now this one says that multiply row 2 by negative 4 and add row, multiply row 2, row 1 by negative 4 and add row 2. So multiply here negative 4 and add here. So that's how I get a 0. Multiply here negative 1 out of 4 and add here. That's negative a half plus 1. Plus 1, which is a half. Multiply here negative 4 and add here. Negative 1 out of 1 and here, so this is a 0. The same thing here. Multiply this, multiply negative 1 over 3 on the first row and add the fourth row. So negative, that's a 0. Negative 1, negative 2 plus here, that's negative 1. Negative 4 plus here, that's negative 3. So that's what we have. And we call this our A1. So after getting that, you see now we are reducing this. Whatever we are doing right now is basically to get the upper triangular matrix. So you can observe these columns, this one there, that they have already gone to 0. So our aim now is to change this to 0. So what do we do? So what we do is now we look at the maximum in this submatrix. So what is the maximum in this submatrix? Our maximum is 3. We look at the magnitude. So I want to put 3 in this position here as our pivot. So what do? I also find another M. So I find another M. Now I use another permutations. So this time around I can be like my P2 is going to be so I want to switch the rows first. Can switch these rows first. So how do you switch? The first row you have no problem with it. I want the second to become the third. You're doing something like this. So you want the second to become the third, so this is that. Something like that. And then my P. So yeah, when I change that, when I have my P2 times A1, so you multiply now this P2 times A1. A1 is this. So now you want to put 3 here. So I have switched it. Now I have to work with the rows. So what do? I get another permutation Q, which can move this there. So my permutation Q2 is now changing these 2 columns. You have no problem with the first column. It's the second and the third that you want to change. So that's why I have that. So therefore you see that when I get my P2 times A1 times Q2, so now this is supposed to be 4. The first column I have no problem with it. The third has to interswitch. This is 2, this is negative 1, this is 1 out of 2. Something like that. So we have our, so you find that we have our upper. Is it upper yet? Yeah. It's upper, but we have to continue and proceed and find the M. So, for now my M2, which is given by I plus M2 E2, so this is equal to, but in this case if you observe, here there is already a 0, so you don't really need to divide by negative 3. Because you have to divide 0 by negative 3. I'll have 0, 0, then I will have 0 divided by negative 3 here. But this is a 0. Actually, negative of 0 divided by negative 3. So you find that I just have a 0 still. Multiplying by this is 0, 1, 0. But this will just give me the identity. Something like that. So when I multiply now this M2 times P2 A1 Q1, you remember now M2 is the identity. So I will just get this 42, I've already got it for 42, 0, negative 3, negative 1, this is 0, 0, 1 out of 2. So we have something like that. So now this is, can call this our A2, but this is the upper. That is our upper triangular matrix. So we have gotten the upper triangular matrix, then we need to get the lower triangular matrix. So we see that to get the lower triangular matrix, we begin from the upper. We see that this M2 of ours multiplied with P2, then but P multiplied with P2 and A1. A1 was this. A1 is here. So you carry the M1, and this is our A1. That was our A1. Then Q. What was our Q2? P2. This is Q2. So this is Q2 here. Remember, this is A1 here. So, but this is equal to, we said that this went to U. So you find that, so you let, you come and let, your, so we come and let our capital M be this, let our Q be that, and let our P be that. So we come and see that this is going to be now, this is just like capital M B, because this is capital M here, and this is Q. However, this is equal to U. We did this earlier in the previous video, so I can multiply here by the P inverse because we know this is an identity. BQ equals to U. So you find that I can then take the M P inverse, like the inverse of this, on either sides. So therefore, this one goes with this, then I remain with PBQ equals, this is P, this is M inverse U. Something like that. Therefore, now this is what we call our lower triangular matrix. It's LPM inverse. Now the issue is, how do we find L equals to P M inverse? But what is P? What is M inverse? Our P, we know that our P is given by P1 times P2. So P1 and P2 we have computed earlier. This is our P2. Then our P1 is somewhere here. So we get them and multiply them. So we get them, then multiply them. So we got these ones earlier, so you come and multiply. The first row has no problem. How do I know? Because this is just the first identity. The second row is still the same, so maintain the second row. Maintain the first row. Respect to this, then maintain the second row also. Yeah, then keep the third row. Whoa, this is interesting. Yeah, this was just the identity, by the way. P2. P2 is just the identity. Okay, so this is an interchange P2. P2 was not the identity, so I've just corrected it. So this one, multiply this, bring the third row. This is what this means. Bring the third row. So the third row is 0, 0, 1. Then here, the second row. Second row with respect to this. Third row with respect to this. Something like that. Okay, so we have our P2. So what about our M inverse? So we say that our M inverse equals to, this is P1 inverse, this is M1 inverse, this is P2 inverse, this is M2 inverse. So therefore this is equal to, so you should know that my P1 inverse is the same as P1 transpose. And for my M inverse, M1 inverse, I just have to change the sign. It's just the change of the sign. For example, so you see what we have been saying. So my P inverse is P transpose. So my P2 inverse is P2 transpose. Then if for my M1, its inverse is just making this positive and that positive, full stop. So this will be 1/4. This is 1 just. This is 0, this is 1. So that's the inverse. We do the same for M2. So what is our M2? So our M2 is just the inverse. So it can be written in this format. Okay, then we proceed. Therefore now we can solve our expression to get capital M. So our M inverse, we said it was this, but we have just seen that our M2 inverse is I. So this is just going to be this. This is M1 inverse. This is P2 inverse. So therefore my M inverse is equal to, so but we say that our L was equal to P M inverse, but our P is P2, P1 inverse. This is M1 inverse, P2 inverse. And therefore this is going to be P2, and this is M1 inverse, this is P2 inverse. So therefore my L is equal to, so you find that this is therefore equal to, so if I try to multiply this, keep the first row the same. Now this is just a permutation, so I'm just interchanging. The third row should come, then the second row, 1, 0. Then with this, then 0, 1, 0. So this is the same as so keep the first row the same. The second one, get the first row, add the second row, add the third. This and this is 1. This and this is 1. This and this, that's 0. Then again, get the first row, multiply by a quarter, and add the second row. First row multiply by a quarter, add the second row. First row multiply by a quarter, add the second row. This multiply by a quarter, add the second row. So this is a 1. So this is our lower triangular matrix. So the moment you have your lower triangular matrix and you also add our U, the upper triangular matrix, then you have finished. Finito. So that's what is required for LU decomposition using complete pivoting. Thank you. Please like and subscribe. More videos are coming. Going to do more examples for Gauss-Seidel method, example for Jacobi, and then how to use the MATLAB for it. Thank you. Have a beautiful day.